In this video, let's work on Lab 5 together. Before watching this video, make sure you have already tried those exercises by yourself. First one, calculate the following values using SAS. In SAS, if you want to calculate value, you need to create a dataset and put those values in that dataset. Yeah, so let's first probe, and maybe we will print the value after this dataset is set. Okay. The first one, we want to compute this probability and this one about z, and z follows the standard normal distribution. If you want to evaluate the probability involving a random variable, so we will use a function CDF, yeah, and you just need to express this probability in terms of CDF. So notice, CDF by definition, it is a probability smaller than some value, right? So here, like first one, so we want the probability larger than this value. So then we just use 1 subtract the CDF at 0.16. Yeah, so first one, P1Z, okay, equals 1 minus the CDF of normal. So the value is 0.16. For the second one, that's the probability between two values, right? So we just compute the difference of the CDF at these two values. Yeah, so one is 1.5, the other is negative 0.24. Okay, so this will be CDF. So we will have normal 1.5 minus the CDF of normal at minus 0.24. Yeah, so let's run this one. You can see, so SAS can give you these two values. We continue. So this next one, this is quantile. Quantile. So which is a number? So notice, so this is a number defined as, so the probability larger than this number is 0.01. Yeah, so it means the subscript. So this number indicates the probability to the right of this value. So notice, for quantile, by definition, so that means the probability to the left of that value, right? So basically, so this the 0.01 is essentially 0.99 quantile, right? Because 0.99 so is the probability to the left of this value. So we will get this as the probability, the probit. Yeah, so this is used to get the quantile of standard normal distribution. Essentially, we just use 1 minus 0.01. Yeah, so this will give you the quantile. Yeah, so this is the quantile. Now, so this is probability to the right of a value. So now it follows a t-distribution with 6 degrees of freedom. So we still use CDF. Yeah, so this is the larger than a value, right? So we will use 1 minus the CDF. So this will be probability of t-distribution, right? So with 1 minus CDF of t-distribution, the value is 1.25, degrees of freedom is 6. Okay. So next one, so similarly, so this is quantile, so upper tail quantile, right? Yeah, so the alpha is 0.025. So we just use t-inf, right? We will 1 minus 0.025. The degrees of freedom will be 6. Next one, so that's F distribution. So notice F distribution will have 2 degrees of freedom. Yeah, so they are called the numerator degrees of freedom and the denominator degrees of freedom. Yeah, so also it is larger than 2.3. Yeah, so we use 1 minus CDF. So the probability of f is 1 minus CDF. Distribution is f, right? Value is 2.3. Degrees of freedom will be 3 and 18. Next one, so this is f, upper tail, quantile. Yeah, so this alpha is 0.05. So we will have f, it should be the inverse. Use function f inverse 1 minus 0.05. Degrees of freedom is 3 and 18. Okay. Next one, chi-square distribution. Yeah, so greater than 2.9. Yeah, so we use 1 minus degrees of freedom. So will be 1 minus, sorry, not 1 minus degrees of freedom, 1 minus CDF. Yeah, so will be chi-square, right? And so then you 2.9, so that's the value. 3, so that's the parameter, degrees of freedom. Yeah, so the last one seems we also needed to get another upper tail quantile. Yeah, so 0.01. So just use Cinf, the function 1 minus 0.01, degrees of freedom is 3. So you run this one. Well, so then SAS will give you all those values you want. Check the log window. Seems everything is fine. So no error or warning message. Yeah. So this is the first question. Second question, so load the following 4x3 matrix into SAS by completing the code below. Here you can see we have a data step, so input value. So those are just the value in this matrix. I think so we just put the number in the order of column. Yeah, so first column, then second column. See, these are the first column, right? So value in the second column, and then value in the last column. The resulting data set contains 3 variables. So we have row and column and value. So value, of course, just will be those value in the matrix. So row just indicate which row, column indicate which column. Yeah, so for example, so this number, right? So the row should be 3 and column should be 1. Another one, see like this one, see the row should be 2 and column should be 3. So let's see how to do this one. In fact, so this is a yeah. So if you are if you have experience in other programming language, and so you will know. So this is a common trick used. So basically, just need to find. You just need to get the row, I mean which row and which column, just from the index of that value. So what I mean is, see, if you matrix, if you run this one, suppose I have another variable called n underscore n, right? Yeah, so this just indicate the n underscore n. See, if you run this one, we have value, right? So n, I mean the first row, so this is the first one. See, like this is I mean the 5th number, right? So the last one is 12th number. Essentially, we just want to get a function based on this n, right? So then we will have the row and column. Well, so if you so we just use this function, like see n capital N, just this n, so it's -1, and so this one divided by 4. Okay, then we choose the integer part and +1. Why this is 4? 4 just the number of rows in this matrix. And so use n to minus the column -1 times 4. So then this, if you run this one, by this trick, see, So first one you have 1, 1, 1, 1, right? See, because they indicate the first column, then 2, 2, 2, 2. Yeah, because those numbers are in the second column, then 3, 3, 3, 3. Yeah, so those are in the third column. Yeah, and so see the value of row, so they are just 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, right? Yeah, so by this way, so then this n is not needed anymore. Yeah. See, by this way, we just get the row and column for each value. So this is the code. Okay. Question 3. So read the following file. So let's check. So what's this file? Seems those are first ID, right? So then we have year, month, day. Year, month, day. Yeah, so they are the birthday, okay? Yeah, so I mean which year, which month, and which day. So they are the birthday of those individuals. Then we have the height, weight, and sex of each of the individual. What we want to do is it contains, yeah, so the birthday, gender, height, and weight for some kids. So first, let's load the data into SAS. So file name, I call it file 1, URL, yeah, because so this is a web link, right? So remove this extra space. Then prog import out equals children, right? The data file is just this file 1, dbms, so this is CSV replace. Yeah, so prog print. Oh, I think so. This data is not that large. Okay, yeah, we just prog print. Data is children. Okay, so run it. Well, so since the data are loaded properly. First question, so define a variable BOD, so that as the date of birth for the kid. So choose the correct format so that the date of birth will display as MMDDYY. See, this is MMDDYY10, right? So this format. In this data set, so we have the year and the month and the day. Yeah, we just need to create a date of birth based on this one. Data, so I just call it children, set children. Yeah, so I just use the same name for the data set. So I just use essentially because I just want to add one row, right? So in that data set. MDY. So this is a function, so we can combine those three variables to a SAS date. Yeah, so just month, day, and year. Notice SAS asks we use appropriate format, right? DOB, so we use MMDDYY10. So make sure to write this dot in the end. Run prog print data is children. Yeah, so let me run this one. You can see, yeah, so you can compare some of them, make sure the data, so the value of the date of birth is correct. Okay. Next one, so change the value of sex from male and female to male and female. Difference is, see, originally male and females are all in lowercase letters, but we want to change that. I mean, for the first letter to be capital letter. Yeah, so this is just seems we can use the function proper case. Yeah, because for a proper case, just the first letter is capital letter and the remaining letters are small letters. So we just sex equals prop case sex. Yeah, so let's run that again. See, male, female. Yeah, so this is what we want. Next one, create a subset containing girls so who were born after June 1st, 2012. Yeah, so first should be girl. Yeah, just means female, right? Then the date of birth should be larger than that. We just create a data set, girl. Set children, right? So then we will use if. So the first sex should be female. Okay, and the date of birth should be larger than. See, you need to know so how to represent a date in SAS. So then you will use 1 or 2 digits to indicate the day, and 3 letters to indicate month, and so 4 digits to indicate year. Yeah, so this should be included in a quotation mark. After that, so you need to write a letter D. Yeah, so this is the appropriate way to represent a SAS date. So for print data girl, right? See, all of them are females, and so then the date of birth is larger than June 1st, 2012. Okay. Next one, create a subset containing all boys and girls who were born on Monday. Monday, okay? Yeah. Date, Monday. Set children. So can be either boy or girls. So of course we want to Monday, right? So then we will have a function called weekday, right? So we just get the weekday from the date of birth. So notice in SAS, for weekday for this function, for Sunday is 1, Monday is 2, and Saturday is 7, right? So for Monday, so essentially we want this equals to 2. Okay. For print data will be Monday. Yeah, so you run this one. So this just will be all kids who were born on Monday. So this is the solution for this question. Next one, download the following data. Let's check. So this is university. This is Excel file, right? You can not Excel file, the CSV file. So it has university, office, and address, and city, state, zip code, and the phone number. Okay, so let's first load data. File name, file 2, URL. So proc import data will be the university, not data, the out equal. Yeah, so this specifies the name of the data set. So then the data file, so will be file 2 and dbms. So this should be CSV and replace. Okay, so then we print this data and run. Okay, so well, so looks like the this is loaded correctly. So we have university, we have the office, address, city, state, zip code, right? And so after that we have phone number. What's first question? For the variable university, all values should be in proper case. For example, so Auburn, so should be Auburn. Yeah, so the first one, every letters are in capital letter, right? So then we want the first letter is capital letter and the remainings are small letters. So the word of should be remain in the form of instead of Let's see how can we do it. So data university updated. Okay, so set university. Yeah, so what we want to do is see, because this information is there, but it's messy, and we just want to use some functions to make this format looks like uniform. So the first what we want to do is university. See, the first letter is capital letter, right? Yeah, so then we will prop case university. Okay, yeah, so then let's run the output to see whether it works or not. For the first one, looks fine. Yeah, but however, for this off, so I want to this O, I want to it remain to be in a small letter. So how can we do it? Well, I think what easiest way is we just forcibly or explicitly just change this off to off. Yeah, so then I will say just for the university, right? I use train word. So train word, so just replace some word, right? So university, I want to play off to off. Okay, yeah, so then let me run it again. So now looks fine, right? See, these off are small letters. Second question, for the variable office, all value should be in proper case. For example, office should be in office. The word off should remain in the form of off. Well, so seems similar, right? Similar to the university. So then I will do the same. See, office. Office is a proper case office, and office is train word office of to off, right? Yeah, so let's see whether it works or not. But there's one issue, right? You can see office also start from OF. Yeah, but when you change this OF to small letters, so things also change these to small letters, right? Yeah, so how to fix that? So notice for this off, you want to change it. So this is a word, right? Yeah, but this OF, so this is not word. But for word, so then you will have a blank before it and a blank after it. So then when you do this search or replacement, see, if you have one blank in front of it and one blank after it, right? So then this should be fine. Yeah, you can see this, the first OF, so this is O is still in the uppercase. Yeah, but this off, so they are in the lowercase, right? So this is fine. Okay. This part is done. For the variable address, so what values should be in proper case? Yeah, so for example, campus should be campus. So write this NE instead of NE and N instead of N dot. Yes, and remove extra blanks. So also first in proper case, address. Let me run this one. Looks fine. But this N, so this dot, so we do not want that dot. Yeah, so then we can just remove. See, the dot is a punctuation, right? Yeah, so then we can remove the punctuation. So address equal to, we use function compress to remove that dot. Address, remove p indicate a punctuation. Yeah. So then we run that. See, there's no n. Okay. Oh, and for this ne, so should be replaced to ne, right? How to do that? Well, I think so we can use the train word again, right? We can use the train word again. Address is train word address ne to ne, right? Yeah, just make sure, because for this ne, there's a blank before it, blank after that. So then I write a blank before it, blank after that. Yeah, just in case. So there, I mean ne, so those appears in other places. Yeah, so now this ne looks fine. Here I says remove all extra blanks. In fact, we cannot see extra blanks. So if you show the output in this way, if you use ODS listing, right? So the file is home output.txt. Yeah, so if you show this in the text, in the listing output, so then you will be able to see that extra, I think so, address, you can see South Jackson Street, right? Yeah, so since we should have only one space and only one space in this E, see, there are only also multiple blanks. So to remove multiple blanks, and I think the easiest way we use function com bl. Yeah, so see, just in here com bl. Yeah, so I first remove the blanks, and so then I change that to proper case. Yeah, so let me run it again. So then you check the output. You can see, I think so. See, there's no extra blanks, right? Yeah, so no extra blanks. Okay. What else? Define a new variable, so which is the length of the characters in the name of office. Name of the office. So office length. Yeah, so because we can use length n function. So this should work. I comment it out, yeah, because I just directly show the output here. Length, right? So this is the length of characters in Office. Okay. Next one. Add a new variable city, so which is the city where the university is located. We have the variable, so city, state, zip code. You can see, so the first word, so should be the name of the city, right? Yeah, so then I just extract city from the first word. So city will be first word, right? We use scan to extract word. So city, state, zip code, the first one. It should be separated by blank. Yeah. See, the last one is city, and we also want, yeah. See, some are capital letters, some are in proper letters, proper case, right? Yeah. So then we just wrap it inside of the proper case. Yeah. So to make the name of the city looks better. so city. Okay. The next one, add a new variable where is the state. Okay. For state, so basically, so the second word will be state. Yeah, and here you can see, so usually, so for state, so we will use the capital letters for that, right? Yeah, so then we will have the state will be capital letters, so uppercase, the scan, ct, state, zip, second letter, right? Second word, sorry, second word. Okay, right, see, we have the state. Define a new variable zip code, zip, okay, so which is the 5-digit zip code of the city. So we will have zip, seems it is the third word, city, state, zip, third word. Run that. Well, so notice some of them has only 5 digits, yeah, but some of them, so they have extra numbers, extra digits. So essentially, so here we only want to keep the 5 digits as zip code, right? So it means we just want the first 5 characters. So in this guy, so then we will do 5 characters, right? So we will do the substring. Yeah, so start from position 1, the length will be 5. Yeah, so this is how we write it. Okay, right. Yeah, so we have the zip code. Phone number should be in the format in this way. The current phone number is, well, they are in different format, right? So sometimes, so they are just 9 digits. Yeah, so sometimes, so they are in see, like parentheses to indicate the area code, and see, sometimes has no parentheses. So how can we do that? I think so. The first, one approach to do that is, so first I just want to extract numbers. So I only keep those 9 digits, and so then I will arrange the 9 digits in the way I want. So I will first get the phone num, so only that numbers. So then I will have compress phone kd. What does this mean? So k means keep, d means digit, right? So means for this one, so I only keep the digits, so in this character string. Yeah, so then the result will be, see, then we just extract the digits from, see, the last one, phone number, right? So they're just the 9 digits of those numbers. So then we just want to arrange those numbers in the format we want, see, in the first 3 digits. So the area code will be included in these parentheses. And so then we just write this, what is called. So yeah, so then the next 3 digits and a hyphen, and then the next, next 3 or next 4 digits, right? Yeah, so in total should be 10, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, yeah, so in total 10 digits, yes. Okay. Yeah, so then we just, it is here. So then we just want to define the phone, right? Phone to be, first, we just use a substring, right? So phone num start from the position 1, so the length is 3. The second piece will be the string start phone num position 4, the length is 3. Then substring phone num from 7, the length is 4. So those of all of them, we will combine them. Yeah, so just use this concatenate those string, right? Concatenate those string. So notice here we will add a heaven, right? So concatenate the string. For here, we just need to add a parentheses, and a space after the parentheses in the beginning. So we add another parentheses. Okay. Yeah. So let's try to run it. You can see, yeah. So now see it becomes what we want. Okay. Next one. Just for fun, okay. Change the 5-digit zip code into numbers, and so define two variables, sum and diff. So the sum and diff as the sum and difference between two zip codes of one university and that of the previous university, and then convert the result back to character values in the format of comma w.d. So let's convert that to numerical numbers. Okay. Let's have another one. Data. So I call it fun, right? Set university updated. Okay. Convert zip code to number, right? Yeah, so we just see to change character to numbers. So the name of the function should be input. We will change the zip code. I think function, the name should be zip. We change the zip to number. Yeah, should be 5 dot. Yeah, because the length of that will be 5, right? Okay. Wrong. Change that to numbers, and sum and diff, right? So will be the sum and the difference. So then we will have zip. I just call it sum, right? So it will be the zip num plus the leg zip num. Yeah, so just add the zip code of the previous university. So then we will do the diff, right? So this will be the diff of the zip num. Okay. So let's check that. See, we have the sum and we have the diff. Okay. So what's next? Yeah, so next, so we want to convert those this back to character. See if you can check the proc contents. Proc contents data is fun. For sum, not sum is here. Now is numerical, difference is numerical, right? Yeah, then we want to change them back to character. So to change them back to character, so we need to use put. Yeah, so then I just use comma 10.0. Yeah, so this one is put and comma 10.0. So run this one. See, they are in proper characters, right? So then you check the sum and the diff. Sum, see, it is character. Diff is also character. Yeah. So this is this one just tells you. I mean, just want to do some exercise using the function input and put. Okay, so this is fine. So now we have the last question. Run the following code to simulate a dataset containing 10,000 observations and 10 variables, where each number follows a standard normal distribution. Construct 95% confidence interval for the mean of the 10 numbers in each observation. How many number of confidence intervals include 0? Well, so if you took a introductory statistical course before, right? So you will know if you construct 95% confidence interval. Yeah, so this just means if you construct if you keep sampling, right? So if you do you create multiple samples. And so for each sample, if you construct such a 95% confidence interval, then 95% of those intervals will contain the true parameter, right? So this is the meaning of this confidence level. So here, so basically I just ask you to run simulation and just try to verify that. For here, so we use a do loop. We haven't discussed do loop yet. Yeah, so basically, so you just run this piece of code and we will explain this code later. Okay. Yeah, so first you run this code and to make sure so it runs. Just display it anyway. It's missing. I know what's going on. See, this one should be quotation mark. Yeah, but when you copy paste here, seems it is changed to a different character. Yeah, so then basically you need to change those to quotation mark. Yeah, so you need to change those to quotation mark. Change those to quotation mark, and so then right. This is not. Let me cancel that first. So I will tell you a trick. Of course, here. So I just ask you to run that from 1 to 10,000, right? So in the beginning, so if you just want to, just try to check your code, yeah, so you can just change this to a small number, maybe just 100. So we run this one. If it works, and so then we just change that number to 10,000. Okay. Yeah. See, those are just each row we have a sample of size 10, right? First question, compute the confidence interval using proc means. How can we do that? See, so notice, so now to compute confidence interval using proc means, because we want to compute confidence intervals for each row. So basically just for each of those 10 numbers, right? So if you want to, but if you use proc means to compute confidence intervals, so this procedure so only compute confidence intervals for one variable. Basically for multiple observations. So if you want to use this function, so first you need to transpose this one. See, for this row, so you need to change that to a column, right? Yeah, and so then SAS is able to compute the confidence interval. So what I mean is, well, so first you need to transpose your data. Okay, so the data is simulate out will be, let me call it maybe long. Because right now, so we have wide data, right? Wide data, so just means one one observation with multiple variables. So long data just means the multiple observations. So not multiple observation, multiple subject. Yeah, so may take multiple rows. Yeah, so this is long data. Okay, and run, right? So then we will have the variable we want to change will be from x1 to x10. So those are the variable we want to do transpose. And so by I, see this I, the first variable, right? So just indicate, which sample it is. Yeah. So after you do that, print data simulate, not simulate, data long. Okay. Run that one. Looks fine, right? Yeah, but see the name you may want to change it. So the job, so this core L, core 1, right? So you may want to change that to a different name. Yeah. So then here, I just write a name. I want to call it replicate, and for this out, right? So then I want to rename the core 1 to be x. Yeah. So let me check that again. Yeah. So now, so it looks fine. So then we want to compute the confidence interval, right? The confidence interval for each 10 observations. Yeah. So essentially we just do that for each distinct value of I. Okay, right? So this just means, see, we will do proc means data is long, right? And we want to get the variable will be x, right? So we will do that by I. So then output out, I want to get, this will be the result 1 CLM, LCLM, so this will be the lower confidence limit, UCL, UCLM, so this will be the upper. Yeah, so the lower and upper confidence interval. So then you print data, you want to show the result 1 CLM. See, for confidence interval, SAS just give you the lower and upper bound for the confidence interval. See, I just indicate so which sample it is. Right? Yeah, so then you get the confidence interval. So now, yes, another comments. Yeah, so for those output of those proc means, right? So if you do not want to, SAS to display it, you can use option no print. Yeah, so because we just want the data set from output, generated by the SAS, right? So by proc means. Yeah, so see if you run this one, so SAS will not show you any output of the proc means. Yeah, so only print this data set. Okay, so the next, compute the confidence interval using SAS function, so such as mean standard deviation in the step. So notice, so I give you the formula for the confidence interval, just use the sample average plus minus. So this is a critical value times standard deviation over square root n, right? So then we can get that. So data, I will call it result 2, right? So set, we just use simulate, just start from the original data. So I mean this one, right? See, we have those 10 variables in one row. So we just compute those in each of the row, because we have x mean. X mean will be the mean of x1 to x10. Yeah, so notice, so this of is required. So if you want to mention a list of variables, so then x standard deviation, so that's std of x1 minus x10. Then the lower confidence interval, so will be x mean, right? So minus TINF, so the critical value 0.975, the degrees of freedom is 9, right? So times xstd divided by the square root of 10. Similarly, so you can get the upper confidence interval, the upper confidence limit. So will be the average plus TINF 0.975, degrees of freedom is 9 times xstd divided by the square root of 10. Okay. So let's print data equals result 2. This is this one. You can see, so we have the x mean, x standard deviation. We compute the lower and the upper, right? Can you check by code, so whether the confidence interval computed by these two methods are equal? So what I mean is, see, for the first one and the second one, so we can print them together. For the first one, see, I have we have lower, we have upper, right? So for here, we also have lower and we have upper, right? So whether they are equal or not. Well, so then how to do? If we want to know whether they are equal or not, so we just do subtraction, right? So use one value, subtract the other value. So if the value equals 0, so they are equal, right? Yeah, so what I can do is, see, from this data set, first data set and the second data set, we just merge them together and merge them by I. After merging, after it merged, right? So we just do the subtraction. So I calculated the difference of lower and the difference of upper, right? And so then this is how we check it. So then we can create a data compare. So then we will merge result 2 and result 1. Result 1, so that is called CLM, right? By I. Notice, see, for lower and upper, because they have the same name, right? So then we need to rename some of them. Yeah, so we need to rename, because for this one, lower, I just call it lower 1. Upper, I just call it upper 1. Yeah. So then I will do check, basically check lower. So I just use lower minus lower 1. Check upper, right? So I just use the upper minus upper 1. Yeah. So then we can print data will be this compare and run. See, we have check. So notice some of the value of these, but some of those are very small numbers. So why this will happen? This is just because, well, so in numerical computing, right? So usually, so that, if you compute the number from a different formula, so it is common that you will get the value. You will generate some running errors. Yeah, so running errors. So although in terms of formula, so the two numbers should be equal. Yeah, but in practice, so they may be off by a very small, tiny number. So then we can just check what those numbers, right? So to see how large they are. In fact, so it is better. So you will use the ABS. I mean, just you get the absolute value of those. Yeah, because because you want to know the difference, right? Yeah. So if some are positive, some are negative, so those positive, negative may cancel out. Yeah. So then you want to use absolute value. So then you just get the proc means data is compare, right? So you just want to check this, check lower and check up, right? Yeah, so you want this one. You can see the mean are extremely small and standard deviation are also extremely small, right? See, this is 10 to the power of minus 16. Yeah, so I think so that can be negligible. Yeah, so then we will conclude they are equal. So equal, yeah, I mean, so just the confidence interval computed using these proc means and those computed using this summary function. Yeah, so they lead to the same result. The next one is how many number of these confidence intervals include 0. Include 0, right? How to check that? Let me show you one of the data. So maybe the results too. Okay. What you can check is, see, you just first you need to check for each of them, right? So if it is include 0, so if you will, if it includes 0, so then you will assign create a variable and so give the value 1. Yeah. So if the confidence interval does not include 0, so the value will be 0, right? So basically you will have a bunch of 1 and 0. And so then you just get the proportion of ones. So then that will be the proportion of confidence intervals include 0. Yeah, so for this purpose, I think I just add one extra here, right? I call it include. So if, how can we tell the confidence interval include 0? So if the confidence interval includes 0, right? So it just means one number will be positive, the other number will be negative. So if you compute the product of these two numbers, right? See, for both, if both endpoints are positive, positive times positive will give you positive. If both are negative, right? So negative times negative will give you positive. Yeah, so it means if the product of these two numbers is positive, so then the confidence interval does not include 0. So if the product is negative, right? So then just means so one number is positive, one number is negative. So then the confidence interval include 0, right? Yeah, so then with this in mind, so then we can just define include will be the lower times upper smaller than 0, right? See, if the product is smaller than 0, just means so one is positive, one is negative. Yeah, so then this confidence interval will include 0, right? Yeah, so I run this one. See, in the last column include, we have most of them are 1, so occasionally we have some 0. Then we use proc means data is will be result 2, right? So then I just the VOR will be include. You can see, so the mean is 9.94, just means 94% of those, right? So for 94% of those, the mean is 0. Also, I mean the confidence interval includes 0. Oh, Another way is, well, I think so you can you also use a proc frag, yeah, if this is easier to understand. So proc frag, yeah, because you do that one. See, include, right? So the value will be either 0 or 1, right? See, 94% of them are 1. Yeah, means include 0. Okay, so this is the last question. Well, so because here we only run this one for 100 times. Yeah, so then let's change that to 10,000. If you want that to 10,000, so you may want to comment out. So those with print, yeah, because you do not want to. It takes too much time to print those. Okay. I just comment out those print. Yeah, so then let me write. See, first one, so this one is a result of this. I mean, we want to check whether the confidence interval are equal based on the two different ways to compute them. Yeah, you can see. So mean standard deviation both are extremely small. Yeah, so the lower and lower and upper endpoints for the confidence interval are equal in those two different data sets. So the next one, so this just want to compute the percent of ones or the percent of confidence interval include 0. Yeah, so you can see, so now it is 94.89%. Yeah, because we want a 95% confidence interval, right? So this number is very close to 95%. Yeah, okay. So you can check the code.